Top 5 tomato diseases and how to beat them for bigger yields. The silent killers destroying your tomato profits. Here are the 5 disease destroyers and your victory strategies. Disease killer number 5, tomato leaf curl virus, the stunting devastator. The 5th disease enemy and unique among our 5 killers because it is caused by virus rather than fungus or bacterium is tomato yellow leaf curl virus, abbreviated as TYLCV, and related leaf curl viruses. Diseases transmitted by tiny white fly insects that suck plant sap and in the process inject virus particles into plants, causing devastating systematic infections characterized by severe leaf curling, yellowing, stunting, and flower abortion that dramatically reduce or completely eliminate fruit production. Leaf curl viruses have emerged as terrible threats to tomato production across tropical and subtropical regions in recent decades, as their white fly vectors have become increasingly abundant and widespread. And unlike fungal and bacterial diseases that can be controlled with pesticides, viruses have no cure. Once a plant is infected, it remains infected for life, never recovering, and serving as a virus reservoir infecting additional plants. The financial devastation of leaf curl viruses is total in severely affected fields. Yield losses of 70 to 100% are common in epidemic years as infected plants produce zero marketable fruits despite normal growth inputs, representing complete loss of 6 to 8 million shillings in potential income that farmers invested to produce but which viral infection destroyed. Therefore, understanding leaf curl virus biology reveals why it is so uniquely challenging and what control strategies actually work. The virus is transmitted exclusively by white flies, specifically Bemisia tabaci, biotype B, which has become globally invasive in recent decades. White flies acquire virus when they feed on infected plants, sucking sap containing viral particles, then transmit virus when they move to healthy plants and feed, injecting saliva containing virus into plant tissues. The virus spreads systematically throughout the plant through the phloem tissue, reaching all parts of the plant within 2 to 3 weeks of infection. Symptoms begin appearing 10 to 15 days after infection. Youngest leaves show curling upward and inward, with margins appearing rolled, and between leaf veins, yellowing appears, creating a distinctive mosaic pattern. Infected plants are severely stunted, often reaching only 30 to 50% normal height. Internodes are shortened, creating compact, bushy appearance, and most devastatingly, flowers abort before setting fruit, or set fruits that remain small and ripen prematurely, never reaching marketable size. The severity of symptoms depends on plant age at infection. Plants infected as seedlings in the nursery or within 2 weeks of transplanting show extreme stunting and produce essentially zero fruits, while plants infected after 8 to 10 weeks, when substantial vegetative growth has already occurred, show symptoms but may produce some reduced harvests. This timing effect is critical for understanding control strategies. The leaf curl virus battle strategy requires accepting that since virus-infected plants cannot be cured and will never produce normal yields, your entire focus must be on preventing whiteflies from accessing your plants to transmit virus, or preventing whiteflies from becoming virulliferous, that is, virus carrying, in the first place. The foundation of leaf curl control is resistant variety selection. Many tomato varieties now incorporate TYLCV resistance genes that don't prevent infection but dramatically reduce symptom severity, allowing infected plants to still produce reasonable yields. Varieties labeled TYLCV resistant or showing resistance ratings in seed catalogs can produce between 400 to 500 crates per acre even under high disease pressure, where susceptible varieties produce zero. This genetic resistance is absolutely mandatory for tomato production in regions where leaf curl viruses are endemic, and attempting to grow susceptible varieties in these areas guarantees total failure. The additional cost of resistant seed, that is 5,000 or 15,000 shillings per acre, prevents losses of 6 to 8 million shillings, making it the most profitable 5,000 to 15,000 shillings you will ever spend. Beyond resistance, implement aggressive whitefly vector management, beginning at the transplant stage. Produce your own transplant in insect-proof screen houses covered with 35 to 50 mesh netting small enough to exclude whiteflies, or purchase transplant only from nurseries using screen houses, ensuring your transplants begin life virus-free without whitefly exposure. This virus-free start is critical because seedlings infected in nurseries arrive in your field already doomed, showing symptoms within 2 weeks of transplanting. Install yellow sticky traps throughout fields at the rate of 20 to 30 traps per acre, positioned at plant height. These traps attract and capture whiteflies, providing both monitoring to detect whitefly presence and mass trapping that reduces populations. Begin insecticide applications targeting whiteflies within 1 week of transplanting, even if you see no whiteflies yet, because by the time whiteflies are visible, virus transmission may already be occurring. Use systematic insecticides, imidacloprid or thiamethoxam, as soil drenches at transplanting. These chemicals are absorbed by roots, move throughout plant tissues, making sap toxic to whiteflies for 3 to 4 weeks, providing critical early protection. Follow with foliar insecticides targeting whiteflies every 5 to 7 days using rotation of different chemical or chemical classes to prevent resistance. Neonicotinoids like imidacloprid, thiamethoxam, acetamiprid, pyrethroids like lambda cyhalothrin, deltamethrin, organophosphates like dimethoate, and insect growth regulators like pyriproxyfen and buprofezin. The whitefly control program is intensive and expensive, costing between 100,000 to 180,000 shillings per acre for a full season of applications. But it is absolutely mandatory in leaf curl endemic areas because the alternative is total crop loss. Apply insecticide thoroughly, covering both upper and lower leaf surfaces, because whiteflies feed primarily on leaf undersides, where they are protected from poorly applied sprays. Use adequate water volumes and appropriate nozzles, achieving complete coverage. Implement cultural practices that reduce whitefly populations. Remove weeds, especially solanaceous weeds like nightshades, devil's trumpet, that serve as virus reservoirs and whitefly breeding sites. Destroy all tomato crops immediately after final harvest, rather than allowing plants to remain in fields where they serve as virus and whitefly resources for neighboring fields. Use reflective silver mulches that disorient and repel whiteflies, reducing landing or plants by 40 to 60%. Plant barrier crops of non-host plants like maize around tomato fields, creating physical barriers that interrupt whitefly movement from external sources. Troubleshooting leaf curl virus challenges requires accepting some harsh realities. If virus symptoms appear on more than 20% of your plant, despite resistant varieties and whitefly control, you are either using fake resistant varieties that are not actually resistant. Your whitefly control program started too late or was inadequately applied, allowing early infection. Or disease pressure in your area is so extreme that even good management cannot provide adequate protection. In this latter case, consider whether tomato production is economically viable in your location, or whether alternative crops would be more profitable. If leaf curl symptoms appear only on field edges nearest to all tomato fields or weedy areas, your problem is viral sources outside your field. Coordinate with neighbors to eliminate these external sources through destroying old crops and controlling weeds. Because individual farm management cannot overcome community-wide virus reservoirs. If whiteflies persist despite intensive insecticide applications, you have likely selected products that local whitefly population is resistant to. Rotate to completely different chemical classes and consider using biological controls like entomopathogenic fungi like Bevaria bassiana or parasitic wasps and Cassia formacea. As part of integrated management, the ultimate leaf curl truth is that this virus is essentially uncontrollable in the absence of resistant varieties and aggressive whitefly management. Attempting to produce susceptible varieties without insect control in virus endemic areas is guaranteed total failure that will bankrupt you. Subscribe to this channel and click the notification bell. We publish comprehensive agricultural guide, disease management videos, variety reviews, troubleshooting contents, advanced techniques, and farmer success stories weekly. Contents potentially adding thousands to your annual farming income. Return regularly because agricultural science continually advances and evolves. New research, refined management techniques, innovative solutions emerge constantly, and improved storage technologies emerge constantly. Consistent learning separates continuously improving farmers from those stuck in outdated methods. Remember to like this video, comment with your story and commitments, share with farming networks, subscribe for weekly agricultural education, and learn on notification or turn on notifications. Your engagement transforms not just your farm, but entire agricultural communities worldwide. Together, we are building a global movement of prosperous, sustainable farmers, proving that with knowledge and commitment, agricultural prosperity is achievable for everyone. Welcome to your farming transformation. Let's make it extraordinary. Top 5 tomato diseases and how to beat them for bigger yields. Summary. This summary is your all-in-one that you need for this tomato farming prosperity. Click on the link in the description below and be able to watch this summary and any other steps and strategies that we have discussed earlier. Thank you.